Now I'm going to talk a little bit about we're going to talk a little bit more about the MapReduce framework. And this is going to be the last video of the semester. Basically, just let's quickly remember the idea of the MapReduce framework. The idea is we're going to have mainly the mappers, but we are going to write code for the mappers and the reducers. But inside the framework, we have also this sorting phase that I will be talking in a couple of minutes. The key point here is that we need to remember that the input for the mappers is going to be all the information that we have inside a Hadoop distributed file system folder. Okay, so basically what we have here is a set of blocks. Okay, so block 1, block 2, block 3, and so on and so forth. This is going to look like a file. Well, these actually are files, but the input is not going to be the file. The input for the mappers is going to be the information of the block, but using the standard input. So this is, for example, if you are talking about Python, it's going to be something that you get, for example, using the input function. And the output of the mappers, you need to have something that is going to be in the standard output, which is something like, for example, using the print. Okay, so basically here the input is going to be uh, the information of the file, okay, whatever file you have, and the output is going to be something with the format. You need to follow this format, the key value format. Okay, so for example, you have key number one, value number one, key value two, key and value number two, key three, value three, and so on and so forth. Okay, so basically this is going to be the output. So the input is the block or the set of blocker or set of blocks, and the output is going to be the key values. Now, what's going on? We are going to have multiple blocks. Okay, so basically what the system is going to be doing is that it's going to be using your code in the different blocks, in the to process all the blocks. And hopefully that's going to be in parallel because multiple uh, you will have multiple programs working at the same time, multiple nodes working at the same time. Okay, so basically this is going to be I quickly covered this last time, but this is a file. Remember that we're going to be processing file. The idea with the Hadoop, with the MapReduce framework is that we are going to be using processing files, huge files. We're going to be dividing the files into blocks. In this case, we have 3 blocks. And then in this particular case, that really depends on your problem, what you have to do, what you have, the processing that you need to be doing. You will have to do something else. But in this particular case, all we want to do is to count the frequencies of the words. Okay, for example, we can see that we want to count the input is going to be this, all this in file, and we want to count. For example, then it's appearing 1, 2, 3 times. Okay, and this is what we get here. Brown is appearing twice, and that's what we get here, and so on and so forth. Everything is going to be processed inside, but we are not going to be working in all the details. So basically for now, let's assume that these are going to be the mappers, basically, and then, okay, so basically your file is going to be divided into multiple blocks. So this is one of the nodes or data nodes that we have. Remember that we have multiple data nodes. Here we have multiple files, and then the mapper is going to process all these files independently, and then it's going to generate the key values. Okay, so here we have key values, key values, key values, key values, and so on and so forth. And then it's going to send that information to the reducers, and I will be talking about that in a minute. Just let's quickly remember this structure that we have in the Hadoop distributed file system. Okay, so basically we have the name node, which is quite similar to the metadata node that we have in the distributed framework of Mongo. So basically he knows everything, he knows how to coordinate everything. And then we have the data nodes. Okay, something different from the Hadoop distributed file system, different to the Mongo system, is that in Mongo system, for example, in Mongo we have a primary node and then we have the secondary nodes. The secondary nodes are identical copies of the primary, and basically we don't use those nodes for processing. We only use those nodes for storing data. In here, remember that what we're going to have is we have blocks. Okay, and each block is going to appear at least 3 times in 3 different data nodes. Okay, so for example, this is block 1, This is block 1, and this is block 1. Okay, and then we are going to have a second block 2. Let's say block 2, and let's say that block 2 is here. And then we can have 4 and 5 and so on and so forth. So basically here we can have, of course, we are going to be using one data node for processing one block. I'm not going to be using, I'm not going to be processing two identical nodes with two different block nodes, two identical nodes with two different data nodes. That's not going to be efficient. So basically here, for example, with this data node, we could be processing block 1. With this data node, we could be processing data node 2. And with this one here, we could be processing data node 3. Okay, so that's the key point. If we have mark, for example, if we have by any chance we have block 4, then in here we will have to process data 4, but we will also need that this block 4 here or block 4 here. That's all that we don't have to take that into account, because all that is going to be done by the system. The Hadoop system is going to be doing all this coordination. It's going to be automatic. Okay, so basically, let's go a little bit to the map phase. Remember that what we want to do is that we want to process one file, and that file is going to be huge. Okay, it could be it would be 20 gigabytes. This is an example. It could be even bigger than that. And then the system is going to be dividing that into pieces, into small blocks. And like this, that we will be processing all that in parallel. Okay, so it's like similar to using the divide and conquer principle. Okay, so basically we have the huge file, we divide that into pieces, and then we will be trying to process all these pieces in parallel. So even though it looks like a lot of work, we will be seeing that if we do it properly, and the system is going to be doing that properly, then it's going to be very efficient, because the blocks are going to be more or less 64 megabytes. This is the default size, but you can change that. That really depends on what you are doing. And then at the very end, you are not going to be processing one huge file of 20 gigabytes, because that's going to be really expensive and time consuming. What we're going to be doing is that we're going to be processing a lot of small blocks of at most 64 megabytes. And all this is going to be processing, and we're going to be doing all this in parallel. Okay, so this is going to scale. This is going to be, if we use more, if we have access to more machines, this is going to be faster. Okay, and sometimes it's going to be even orders of magnitude faster. Okay, for example, and the idea is that, for example, if we have 10 machines, that's going to take X amount of time. But if we duplicate that, then it's going to take half of the time, and so on and so on and so forth. It's similar to what I was talking before, when we want to scale up the performance. And okay, so there are a lot of, you might have a lot of open questions here, because are we going to process, how the mappers are going to be processing all this? Okay, because we know that we have the mapper, and the mappers, they will be processing the blocks. Okay, so we have block 1, block 2, block 3, and so on and so forth. And we have a set of mappers, but how we're going to be creating this mapping between the mappers and the blocks? This is an open question. And how are we going to coordinate that information between the mappers and the reducers? Okay, basically, remember the mappers are going to be in a data node, and basically what is going to be happening inside is that the system is going to be doing all this coordination. The MapReduce system is going to be doing all this coordination. We don't really need to we don't need to worry about that. And they will be doing in a very balanced way. So in a way that all the data nodes they process more or less the same amount of data, the same amount of blocks. And then if all the computers they have the same processing power, then all of them will be finishing almost at the same time. That's the that's the key idea. And we can, if we want, if we need, we can add more processing power or use less processing power. That really depends of you. Okay, so basically this is totally transparent. Okay, so we don't really need to worry about all these things, because the system is going to be creating all the mapping between blocks and mappers and so on and so forth. And basically, what are we going to do exactly? Okay, so what exactly do we have to do? We are dealing with the MapReduce framework. Okay, so basically we can see this as this three-step process. Okay, basically we have the input information for each particular mapper, and then all you have to do is to create one mapper, and then the system is going to be processing everything. As long as you get the concept properly and you process this information with the structure that is required, everything is going to be fine. The input is going to be a file. Well, it's not a file, it's a block using the standard input. Remember, it's going to be, for example, input in Python, but it looks like a file. Okay, and then the mapper is going to be processing this. This is something that you have to write using your favorite programming language. You can use Python, you can use Java, or something else. But something really, really important is that the output must be a set of key values. Okay, so key 1, value 1, key 2, value 2. Depending on what you are doing, you have to codify this in one or another way. And this is going to be the standard output. So print, for example, with print. There are different alternatives. But this is what you have to be doing. And then the system is going to be processing all those blocks properly in parallel and coordinating all the system. So unfortunately, there is no one single way to program and to create to write the code of the mappers. This is open. Okay, it really depends on all your programming skills. You have to write a program. At the end, what you have to do is your mapper is going to be one program, and in that program, you will be reading information from the standard input, and then you will be generating a set of key values. It's really up to you. For example, you can use one for loop in order to process all that information, but that's open. You can do it as you want. It's really up to you. But you have to keep the format. Okay, so the input is coming in from the standard input. It looks like a file, and the output is going to be also in the standard output, but you have to generate key values, and these key values are going to be the input for the reducers. Okay, so you need to do whatever you need in order to process that file. It's really depending on the logic of your program and whatever you need to do. That's the key point there. Okay, remember this is the example that I'm using. All we want to do is to count frequencies. So in this particular case, what we can do is that this mapper is going to be processing all this information. So we find this, and then we create the and one quick, uh, quick and one brown, and so on and so forth. This is what we are going to be doing here in this particular example. So now we need to decide how we are going to be programming the mappers, okay? So, and we need to see how we are going to be processing all those blocks, regardless the size of the block. And we will be seeing how we process that. Well, actually, we don't have to process that. All we have to do is to write this program, which is going to be for the mapper. And then we have to take into account that the input is going to be a block. This is going to look like a file. However, we're going to be using the standard input. This is, for example, if you are working in Python, it's like if you use input, you assume that everything is coming, for example, using input, using the standard input. This is called the standard input, and this is going to look like a file, and then we need to process that, a text file, okay, with a lot of information, and then we are going to be processing that file, and we have to create a set of key values. Okay, so basically the input is going to be file, a regular file, using the standard input, and we need to be generating a set of key values using also the standard input, for example, using print. This is how we process this. That's the key point. Now, there is no one single way of programming that. That's really open. That's really up to you. You have to use all your programming skills in order to program the mapper. That's totally free. You decide how to do it. You can do it. There are multiple ways of doing that. You can do that in Python. You can do that in Java. There are different programming languages that support the MapReduce framework. Okay, so that's really up to you, and then you decide how you program that. As long as you remember that the input for the mappers, for each particular mapper, for your program, is going to be a block using the standard input, which is like you can think as just a program that is receiving information, and then you will be generating a lot of key values. Okay, so you will have key number one and value number one. This is a file. Okay, this is going to be the first line, the second line, the third line, and so on and so forth. And that's really up to you. All you have to do is to take it to write your program. The logic of your program is really up to you. This is totally open. There are no rules for this. Okay, remember, all you have to do is to generate these key values. As long as you generate those key values using the standard input. I might say this a lot of times, but for example, using print, you don't have to write. You don't have to write files, okay? Because this is the Hadoop framework is using the standard input. Okay, so be careful with that. The standard input for getting the information and the standard output for generating the results. Okay, so this is the example that we said that I was talking in the last video. Remember that this is going to be my input file, and what we want to do is to count the frequencies of all the words, okay, in the file. And then this is just a tiny example. You can imagine that this input file is going to be a few hundreds of gigabytes. So basically, this is going to be the file, and the output that I want to see, the final output is something like, for example, that we have here. For example, this word is appearing 2 times, okay, one and 2 times in my input file. So basically, this, even if this word is in different blocks, at the end we're going to be counting two. Fox, for example, is 1 and 2. How is appearing only once, and so on and so forth. Okay, so basically what you have to do is that you will be creating one mapper, and then the MapReduce framework is going to be processing all these blocks in parallel. Okay, basically here you can use all your programming skills, as I said before, and for example, you will be generating this kind of key values. These are the key values that you will be generating. Okay, so you will be reading this from the standard input. You can do this, for example, with a for loop or with a while loop. That's really up to you. And then you generate the key values. Okay, for example, in this case, this is reading the, and then it's processing one, and so on and so forth. For example, something important here, there are different ways, as I said, there are multiple ways of doing this. For example, the mappers here, all they are doing is the key values are the word and the letter, the number one. Okay, indicating that this word is appearing one time, this word is appearing one time, this word is appearing one time, and so on and so forth. We could do something a little bit different if we want. For example, here we have the fox and then the again. So we could have done, for example, the and two. This is another alternative. Okay, but in the first approach, we are doing the very naive and initial alternative. And then these key values are going to be um, sent to the reducers. Again, the output, for example, in order to generate this, we will be using the standard output, for example, using print, and so on and so forth. Okay, so now it's coming the sorting phase. We don't really see this one, but it's important that you understand that this is going on, that this is happening inside, that this is happening automatically happening in the MapReduce framework, because that's going to be important for the reducers. Okay, so basically at this point, basically you might be a little bit confused because of what's going on, but it's quite easy, okay? Basically what we have to do is that we take, the mappers are going to be processing all the blocks in parallel. That's something that we have to be thinking about. Okay, and then we are going to be generating the output. Okay, so basically the mappers, you only create one single program, and then the MapReduce framework is going to be using that program to run multiple mappers in parallel in different data nodes. So that means is that it's going to be happening in different machines, in all the machines that you have for processing your your file, and that's going to be automatic. So you don't really have to, as long as you write that you have a proper logic in your mapper, in your program, that's all you need to know. Okay, so basically the reducer, the sorting phase, what the sorting phase is going to be doing, okay, the sorting phase is going to be taking all these key values and is going to be sorting all of them in order to provide the information to the in order order to forward that information to the reducers in a balanced way. Okay, trying to distribute the process in order to balance all the work that needs to be done in the future. So basically that everything, or that all the data nodes are going to be processing more or less the same amount of information. That's the, the key point. And something extremely important is that all the keys, okay, because at the end what we're going to have is multiple keys, okay? Key 1, key 2, and next one, key value, value 2, key 3, value 3, and so on and so forth. But if I have, for example, key 1 and value 3, okay, we can see that key 1, okay, basically what the sort is going to be doing is that it's going to, this is going to be the input for the sorting phase. What this is going to be doing is that it's going to be sorting, of course, key 1, value 1, key 1, value 3, key, let's put here 4 in order to avoid a confusion. This key 2, value 2, and key 3, value 3. Okay, so basically this is going to be sorting all this. Okay, we have four keys and four values, but now they are going to be sorting that. And then all the keys, and then this is going to be forwarding this to the reducers, many reducers. But something important is all the keys with the same value, they will go for sure to the same reducer. Okay, for example, these two go to reducer 1. This one is could be going to reducer 2, and this one could be going to the reducer 3. Okay, because they will be going to different reducers. But the important part here is that these two are going to be, if they have the same value, they will go to the same reducer. That's really important because otherwise it would be impossible to aggregate the information of the same keys. So we have to take that into account. And this is what we are seeing here. Okay, so basically we process the input, all the input blocks using the mappers, and then, for example, all the keys with the value D, they go to the same reducer. And the same one here, for example, well, we don't have any Fox, for example, this is another one. All of them, they will be going to the same reducer. And that's what we have, and that's what's happening there. Again, this is going to be the framework of the MapReduce idea. Basically, you have a lot of nodes. In those nodes, you can have multiple processing units. For example, here we have multiple processing units. Okay, so basically this is the MapReduce framework that I mentioned a number of times before. We have a number of nodes that will be data nodes, and then we will be processing a number of blocks. Okay, for example, this mapping process is going to be processing certain nodes, certain blocks, and so on and so forth. And then the mappers are going to be generating some data, okay, the key values. So all these guys are key values, key values, key values, key values, and so on and so forth. And then we are going to be sorting and shuffling, okay, so basically in a way that this is no, in a way that we can distribute the data in the best possible way. But with the key, all the keys with the same value, they go to the same reducer. Okay, for example, this one or this one. We don't know. That's the key point here. That's why I'm saying that we shuffle that because we don't know. We cannot control that. That's up to the MapReduce framework. All you have to do is to read the input blocks using the standard input and then generating the key values using the standard output, and that's all. And then the reducer will be doing a different job in parallel. All this is happening in parallel using the different data nodes. Okay, so basically, again, we are collecting the key values and then we are processing all that information. And all this is automatic, so you don't have to. It's important that you understand what's happening inside, but you don't have to take into account into all the details. For example, I don't have to write any code in order to sort. Okay, so that would be automatic. Or I don't have to write any code in order to tell the system that the output of this mapper is going for this node or something like that. No, that's going to be automatic, and all the job is going to be done by the Hadoop MapReduce framework that we have that is running in the system. Okay, so now let's talk a little bit about the reducer, which is the last part of of the system. And basically the reducer is quite much the same. It's very similar. Okay. Now the reducer is going to be taking as an input the output of the mappers. Okay, and it's going to generate the final result. Again, using the key value format. This is something important. You have to start thinking a lot about key values because this is the key point of this framework. Again, there is no one single way in order to do this. You have to write your program, and that's really up to you how you write your program. That's open. You don't have to. There is no one single way of doing that, and you have to do it, for example, in Python or in Java. That's really up to you. And the important thing here that you have to take into account when writing the program is that you will be receiving the input is going to be for each particular mapper a reducer is going to be a set of key values, okay, using the standard input. And then the output is going to be also a set of key values. Okay, so that's the only way that we have to do it. Okay, so this should be programming the reducers. Okay, this is reducers. And basically, we have to start processing all that information. Again, the input is going to be a set of key values, and then the output is going to be a set of key values, and then we're going to be processing all these things. For example, one example of how this works. Okay, for example, or basically what is happening here is that all these three keys are coming to basically the input here. For example, for this reducer is going to be the, this is what we will be seeing: one brown, one fox, one in a single as the input in a single file in a single block. Uh, one fox, one, the, one, the, one, how, one, now, one, brown, one. And all this is going to be the input for this. This is the key and this is the value. And then this guy is going to be processing that. For example, you could be using a for loop in order to process all these input lines using the standard input and then generating and then aggregating that information to generate the output for this particular block. And then all these guys here, this one, this one, this one, and this one are coming for this reducer. And that's all you have to do, okay? All you have to think is how to grade your mapper. It's really up to you as long as the input is going to be a block using the standard input and the output of the mappers are going to be a set of key values and that's going to be the input of the reducers and the output of the reducers is going to be your solution. Okay, and all this is happening in parallel. Okay, for example, here, if you have three identical machines in your cluster, then this is going to be taking three times, it's going to be three times faster if you use this framework to process the mappers. And then the reducer is going to be, well, we only have two reducers, so there is one of the machines that is not going to be working because a lot of the work here, most of the work is going to be done by the reducers, by the mappers, sorry, but the reducers are also going to be processing a lot of things. Again, we don't know. Uh, it's really up to the system to decide how to, what information to send to these particular reducers. That's really up to the system, and we cannot really control that. Again, okay, so basically this is the idea of the MapReduce framework. The idea is to give you an introduction of the MapReduce framework. It's not really that difficult, okay? And then programming this is going to be straightforward as long as you have as long as you understand the key points here. Okay, and that's basically all I wanted to I want to say for this semester. Um, I wish you all the best in the final exam, and I hope that you are all doing well. Okay, bye bye.